Welcome to the Discrete Universe podcast.
Great to be here.
Today we're diving deep into, well, a question that's right at the heart of physics, isn't it? Is time physical?
Absolutely. It's one of those fundamental things physicists and philosophers, too, have been wrestling with for centuries.
And we're going to explore this specifically through the perspective of quantum geometry dynamics, or QGD. It's a newer axiomatic approach.
Right. And it offers a pretty unique take. We've got some good material to draw on, Daniel Bernstein's work, some philosophy resources, too.
Yeah, so our mission really is to unpack how QGD approaches this. Is time fundamental, a dimension, or maybe something derived?
Exactly. Does it flow? Is it a landscape?
Yeah.
Or is it just a way we measure change in something more fundamental?
Okay, so maybe let's set the scene first. How do people usually think about time? Philosophically, I mean.
Well, you generally have two big camps, simplifying a bit. There's the A theory.
That's the one where time flows.
Yeah.
Right? Like there's a definite now that moves.
Precisely. It aligns with our gut feeling about time passing. Then you have the B theory.
And B theory is more like time is a block. Past, present, future, all equally real, laid out.
Yeah, sometimes called the block universe. It sees time more like another dimension, static in a sense.
And special relativity kind of pushed things towards the B theory camp, didn't it? With the whole relativity of simultaneity thing.
It certainly challenged the A theory view. If observers moving differently can't agree on what's happening now across distances, well, it makes a universal flowing now problematic.
Right. A universal present moment sort of dissolved. Which brings us neatly to QGD. It starts somewhere completely different, doesn't it? With space itself.
It really does. QGD's core idea, its foundational axiom, is that space isn't continuous. It's not infinitely divisible.
Okay. So it's discrete. Made of, what did the source call them? Preons.
Preons, exactly. Symbolized as, think of them as the absolute fundamental units, the pixels of space, if you like.
Pixels of space. And dimensions like length, width, height. They aren't fundamental either in QGD.
No, they're emergent properties. They arise from the relationships and interactions between these preons. The geometry emerges from the network, basically.
Wow. Okay, so if space is built like that from these discrete units, how does that change the picture for time?
Fundamentally, QGD operates under a principle of strict causality. And within that framework, time isn't seen as a physical thing at all.
Not physical.
Yeah.
So, what is it then?
It's treated as a purely relational concept. It's essentially a mathematical parameter we use to track the sequence of states, the evolution of dynamic systems built from these preons.
Like the ticks of a cosmic clock. But the clock isn't measuring some external time flow. It's just tracking changes within the system itself.
That's a great way to put it. It's like a sequence counter for the configurations of preons. Cause and effect are about the evolution of states, not movement along a time axis.
Okay, that is a big shift. So, what about things like time dilation? Relativity predicts clocks to slow down at high speeds or in strong gravity. How does QGD explain that if time itself isn't stretching?
Ah, right. This is key. QGD's predictions actually match relativities perfectly in those scenarios. The numbers work out the same.
But the why is different.
Completely different. QGD says time doesn't dilate. It's not time itself that's affected. Instead, the physical mechanisms of the clocks themselves slow down.
So if you have an atomic clock, the oscillations of the atoms actually occur less frequently.
Exactly. The physical processes within the clock are directly affected by the high speed or the strong gravitational field, causing them to run slower relative to a clock in a different environment. It's a physical effect on the device, not a warping of a time dimension.
That makes a certain kind of sense. It grounds it in the physical object. So clocks aren't really time measurers in QGD?
Not in the sense of measuring an independent flowing entity called time. They are counters. They count recurrences of a specific state in whatever periodic system the clock uses, a pendulum swing, a quartz crystal vibration, an atomic transition.
They're just counting cycles of a physical process. And that process can be slowed down.
Precisely. The rate of the physical process changes, not the rate of time itself.
Okay. Now speed. Relativity links time, space, and the speed of light in a very intimate way. How does QGD handle speed, especially the constancy of the speed of light, if time and space are emergent like this?
Good question. QGD introduces something called intrinsic speed. And importantly, it's defined without needing pre-existing notions of time or distance.
How does that work? Speed is usually distance over time.
Right. But intrinsic speed in QGD is defined as the ratio of an object's intrinsic momentum vector to its intrinsic mass. These are fundamental properties in the QGD framework.
So speed is a property inherent to the object related to its momentum and mass in this discrete space.
Exactly. And here's the kicker. QGD identifies certain preons, called preons plus, as the constituents of photons. And when you calculate the intrinsic speed for these preons, plus, let me guess, it comes out as c, the speed of light. Bingo. The observed constancy of the speed of light isn't postulated as a universal speed limit through spacetime. Instead, it emerges as a direct consequence of the fundamental intrinsic speed of the preons that make up light within QGD's discrete structure.
That's elegant in a way. It derives C rather than starting with it.
Mm.
Okay, let's circle back to simultaneity. Relativity says it's relative, but
Yeah.
you mentioned QGD posits instantaneous gravity.
Yes. This is another major divergence. QGD proposes that the fundamental interaction between the space preons, this n gravity, isn't something that propagates. It acts instantaneously between all of them.
Instantaneously, so no speed of light limit for gravity.
Correct. In the QGD picture, gravity's influence is felt everywhere, immediately. And if that's true,
Then simultaneity can't be relative anymore. If event A influences event B instantly via gravity, they must share the same now, regardless of who's looking.
that's the implication. If gravity is instantaneous, simultaneity must be absolute and frame-independent. It's a direct contradiction to special relativity.
Which suggests a very different kind of interconnectedness in the universe, at least gravitationally.
It does, and this different foundation, this discrete space and relational time, leads to different explanations for other big cosmological puzzles, too.
Like dark matter and dark energy. The sources mentioned those.
Indeed. QGD suggests we might not need exotic, unseen matter or energy. For instance, the accelerated expansion of the universe, usually attributed to dark energy,
No.
might, in QGD, be a result of how gravity behaves at extremely large scales within this discrete structure. Perhaps a repulsive aspect emerges naturally from preon interactions over vast distances.
And dark matter. The extra gravity holding galaxies together.
Similarly, QGD proposes that the way in-gravity operates between preons within and around galaxies could explain those anomalous rotation curves without needing extra invisible matter. It's about how gravity itself works in this discrete framework, potentially differently than we assume based on general relativity at those scales.
So, potentially solving two huge mysteries with the fundamental structure itself. What about cornerstone principles, like Einstein's equivalence principle?
QGD actually derives the weak equivalence principle, the observation that things fall at the same rate regardless of composition. That comes out naturally.
Okay, so it agrees on that.
But it challenges the strong equivalence principle, or at least Einstein's thought experiment, about being in a closed box and not knowing if you're accelerating or in a gravitational field.
How so?
QGD predicts that gravitational acceleration and inertial acceleration would actually have subtly different effects on an object's fundamental properties, its mass, momentum, energy. The difference might be tiny, maybe undetectable currently, but QGD says they are not perfectly equivalent at the deepest level.
Another potential observational difference down the line, perhaps. Right, and this instantaneous gravity, what does that mean for gravitational waves? LIGO and Virgo have detected ripples in space-time.
Right. This is probably one of the most dramatic points of difference. If gravity is instantaneous in QGD, then gravitational waves as conceived by general relativity ripples of space-time curvature propagating at light speed shouldn't exist.
So, what were LIGO and Virgo detecting, according to QGD?
QGD proposes an alternative explanation. It suggests those signals could be electromagnetic in nature.
Electromagnetic. How?
The idea is that extremely energetic events, like merging black holes, violently disturb and accelerate massive amounts of preons. This disturbance could cause a polarization effect within the preonic field itself, generating powerful electromagnetic signals that mimic what we'd expect from gravitational waves.
So same signal shape perhaps, but a totally different physical cause. Electromagnetic ripples in the preonic medium, not gravitational ripples in spacetime.
That's the QGD interpretation, yes. A radical rereading of those detections.
And it all stems back really to that first principle. Space is discrete.
It absolutely does. That axiom cascades through the whole framework. It even leads QGD to argue against the physical reality of mathematical continua and actual infinities.
Meaning things like infinitely dense singularities or infinitely divisible space are just mathematical ideals, not physically real.
Essentially, yes. The argument is that any process, any construction, is limited by physical resources and steps. You can't actually perform an infinite number of operations or access an infinite amount of information. So the continuum and infinities are useful math concepts, but maybe not reflections of fundamental reality.
Which ties back beautifully to time, doesn't it? If even the continuum is suspect, the idea of time as a smooth, continuous fundamental flow becomes, well, less likely in this picture.
Exactly. Time in QGD becomes a constructed concept, emerging from the relationships and changes within a fundamentally discrete, finite reality.
So pulling this all together, is time physical? QGD seems to offer a clear no. It's not a physical dimension to be warped or traveled through.
That's the QGD perspective. Time emerges. It's relational. It's a way we map the evolution of the truly physical stuff, the prions and their interactions.
It really forces you to question basic assumptions about reality, measurement, the whole fabric of the cosmos. This idea that our perception of a smooth, flowing time might just be an emergent effect, kind of like the smoothness of a movie from discrete frames.
That's a decent analogy. The underlying reality is granular, discrete, relational. The flow is how we perceive the sequence of changes at our macroscopic scale.
This deep dive definitely gives us, and you listening, a lot to think about. QGD presents this very different but seemingly consistent alternative framework.
It does. It reproduces many successful predictions, but offers radically different explanations. As with any theory, the real test lies ahead. Can it make unique, testable predictions that differentiate it from relativity and the standard model? That's the crucial next step.
A fascinating journey to follow. Could the universe, at its deepest level, be fundamentally discrete, with time simply being the narrative of its changes? That's certainly a thought to ponder.